So, in this class, we will discuss about the linear programming problem. So, linear programming is a widely used mathematical modeling technique to determine the optimum allocation of scarce resources among the competing demands. So, resources typically includes raw materials, manpower, machinery, time, money, and space. So the technique is very powerful and found especially useful because of its application to different types of real business problems, especially in the areas like finance, production, sales and distribution, personnel, marketing, and many more areas of management. As its name implies, the linear programming model consists of linear objectives and linear constraints, which means that the variables in the model have a proportionate relationship. Say, for example, an increase in manpower resources will result in an increase in work output. So, this programming problems in general deal with determining the optimal allocation of limited resources to meet the given objectives. So, the resources may be, as I've already explained, in the means of men, materials, machines, etc. So, a definition we can define this linear programming. Linear means all the relationships in the problem. And programming refers to the process of determining a particular program or plan of action. So George B. Dantzig is recognized as the pioneer of linear programming. In 1947, he published the first paper on simplex method. Since 1947, many other researchers joined him in developing and exploring new application of linear programming. And now linear programming problem is being applied to many areas of human activity and its application has increased with the development of computer technology. So optimization is the way of life. We all have finite resources and time and we want to make the most of them. From using your time productively to solving supply chain problems for your company, everything uses optimization. Say for example, sharing a bar of chocolate between the siblings is a simple optimization problem. So we don't think in mathematical terms while solving it. Linear programming is one of the simplest ways to perform optimization. It helps you to save some very complex optimization problems by making a few simplifying assumptions. It may be defined as a method of determining an optimal program of interdependent activities in view of available resources. The objective in a linear programming problem is to maximize profit or minimize cost, as the case may be, subject to a number of limitations known as constraints. So, in linear programming, an objective function is constructed which represents total profit or total cost, as the case may be. The constraints are expressed in the form of inequalities or equations. Both the objective function and the constraints are linear relationship between the variables. So the solution to a linear programming problem shows how much should be produced, which will optimize the objective function and satisfy the constraints. So in the words of Samuelson, this linear programming is the analysis of problems in which a linear function of a number of variables is to be maximized or minimized when those variables are subject to a number of restraints in the form of linear inequalities. Then, before going to essentials, uses of linear programming. Linear programming technique is used to achieve the best allocation of available resources. So we can say the available resources may be man hours, money, machine hours, raw materials, etc. So as most of these resources are available for a limited supply, the allocation of them should be done in a manner which will optimize the objective of maximizing profit or minimizing cost. So this linear programming is a powerful quantitative technique which can be used to solve such kind of problems. See for example. So examples of linear programming and its application areas. A production manager wants to allocate the available machine time, labor, and the raw materials to the activities of producing the different products. So the manager would like to determine the number of units of the products to be produced so as to maximize the profit. Then second one is that a manufacturer wants to develop a production schedule and an inventory policy that will minimize the total production and inventory cost. And another example is that a marketing manager wants to allocate fixed advertising budget among alternative advertising media like radio, television, newspapers, and magazines. So the essentials of a linear programming model. So for a given problem situation, there are certain essential conditions that need to be solved by using linear programming. The first one is limited resources. You know that the resources are limited and the limited number of labor, materials, equipment, and finance. Objective refers to the aim to optimize. That means for the organization, there are mainly two objectives. First one is that to maximize the profit, and second one with regard to cost is that to minimize the cost. We want to maximize the cost. So the objective should be to minimize the cost. Then linearity means that increase in labor inputs will have a proportionate increase in output. Then homogeneity, the products, workers, efficiency, and machines are assumed to be identical. Then divisibility. It is assumed that the resources and products can be divided into fractions. So these are the essentials of linear programming. Then requirements. So in order to formulate the linear programming problem, following are the requirements. There must be well-defined objective function. There must be a constraint on the amount. There must be alternative course of action. And the decision variables should be interrelated and non-negative. And the resource must be limited in supply. Then properties of linear programming model. It means that there should be a relationship among decision variables, must be linear in nature. A model must have an objective function and the resource constraints are very much essential. A model must have a non-negativity constraint. So formulation of a linear programming problem. So in linear programming problem, the first case is that formulation of it is a representation of a problem situation in mathematical form. So it means that it involves a well-defined decision variable with an objective function and a set of constraints. So objective function. Objective of the problem is identified and converted into a suitable objective function. Constraints means the availability of resources if when or that supply of the resources are limited. So that is considered as the constraints. When the availability of resources are in surplus, there will be no decision problem. But in real life, the organization normally has scarce resources, so within which the job has to be performed in the most effective way. So therefore, the problem situations are within confined limits in which the optimal solution to the problem must be found. And finally, the non-negativity constraints. Negative values of physical quantities are impossible, like producing negative number of chairs, tables, etc. So it is necessary to include the element of non-negativity as a constraint. So this is an example of linear programming problem. Let's say an Amazon delivery man has 6 packages to deliver in a day and warehouses are located at several portions. The number on the lines indicate the distance between the cities, and to save on fuel and time, the delivery person wants to take the shortest route. So the delivery person will calculate the different routes from going to all the 6 destinations and then come up with the shortest route. This technique of choosing the shortest route is called. So in this diagram, it is specifically mentioned that how the distance from the warehouse to various locations, and he has to select the shortest route. So in this case, the objective of the delivery person is to deliver the parcel on time at all 6 destinations. The operations research is an approach to decision making which involves a set of methods to operate a. So finally we can say that this linear programming is used for obtaining the most optimal solution for a problem with given constraints. In linear programming, we formulate a real-life problem into a mathematical model, and it involves an objective function, linear inequalities with subjective constraints. So this is an example of a linear programming problem. Consider a chocolate manufacturing company that produces only two types of chocolate, A and B. Both the chocolates require milk and chocolate. So the factors are given. Each unit of A requires 1 unit of milk and 3 units of chocolate, and B requires 1 unit of milk and 2 units of chocolate. And the company kitchen has a total of 5 units of milk and 12 units of chocolate. This is the limiting factor. On each sale, the company makes a profit. So profit will be your objective function. 6 per unit of A sold and 5 per unit of B sold. The company wishes to maximize its profit. So how many units of A and B should it produce respectively? So in this case, you have to formulate this linear programming problem. So this is just the representation of following items in tabular form. So for producing A, we have this much requirements, and for producing B, we have the requirements. So in this case, how to solve this? Let the total number of units produced by A is x1 and total number of units produced by B is x2. And the total profit is represented by Z. So the total profit the company makes is given by the total number of units of A and B produced multiplied by its per unit profit. That means in the question it is specifically mentioned that the profit from that two products, that is for selling A it is 6 and for B it is 5. So it is represented as maximum. Maximize Z equal to 6x1 plus 5x2. 6 units of A and 5 units of B, which means that we have to maximize Z. So the company will try to produce as many units of A and B to maximize the profit. But the resources like milk and chocolate are available in limited amount. So that is called as the constraints. As per the above table, each unit of A and B requires 1 unit of milk and milk. The total amount of milk available is 5 units. So that means to represent this mathematically with regard to A, 1 unit of milk, that means 1x1, that is represented as x1, and 1 unit of, and for requiring B, 1 unit of milk. So with regard to milk related data, we have to represent x1 plus x2 less than or equal to 5. So the total available quantity for milk is 5 units. And for B also the total available quantity is 12. So with regard to choco, the total available quantity is 12, and choco related data should be represented like 3x1. And that is in the question it is mentioned that, you can look at the question, 3 unit of choco and 2 unit of choco for producing both. So 3x1 plus 2x2, that should be less than or equal to 12. That is the choco related data. That is represented by means of constraints. And we have to specify the non-negative constraint which is there for all the problems. For the company to maximum profit, the above inequalities have to be satisfied. So the problem is formulated like this: maximize Z equal to 6x1 plus 5x2 subject to x1 plus x2 less than or equal to 5, 3x1 plus 2x2 less than or equal to 12, x1 greater than or equal to 0, x2 greater than or equal to 0.